will now invite on my first guest, which is Susan Okereke. So Susan, if you can turn your camera on and your mic. Hello. Are you excited? Oh, what a hat. Amazing.
I also want a big sorry to Matt and Katie. Oops, I jumped in a bit too soon. Sorry.
It doesn't matter at all. It's Friday night. It's all fun. So Susan, you're a teacher, and you're a co-host of the successful podcast, The Maths Appeal, and also you've written puzzles for Radio 4. So, is there anything that you don't do? Tell me a bit more about what you do in your time.
Well, thank you. That's very, very nice introduction, Zoe. Thank you. So I am a maths teacher currently in secondary school in London, and I'm really, really interested in trying to make maths more accessible and more fun for people, because I know a lot of people find it quite challenging, but it's also can be so playful and can be so great. And I want to kind of showcase some of the great stuff there. And with the Maths Appeal podcast that I do with Bobby Seagull, who's actually going to be on tomorrow. And we've actually interviewed you, haven't we, Zoe?
You have indeed,
past,
yeah,
yes.
a while ago.
So we can showcase and do puzzles, and we also do interviews with people who have got really cool math stories, and we want to kind of bring maths a little bit to life. And one of the reasons we just love playing with maths and trying to make it more accessible to people.
Really nice. Okay, that sounds excellent. And you've got a trick for us today.
Yes. So I want to show a way of multiplying a two-digit number by 11 quickly. Okay, so that's the thing. Okay. So that's my trick. Okay. So actually, I'm going to ask people who are watching, can you just sort of, in the chat, just give a variety of two-digit numbers. And then Zoe, I'll ask you in a bit to kind of go to the chat and ask me. But to begin with, Zoe, can you think of a two-digit number, and I'll try and quickly work it out using the calculator that is my mind. Okay.
Not the one on your hand. The one in your mind.
Not one in my hand or in my ear.
Oh yeah, nice. I hadn't spotted them.
Yes, yeah.
Okay. Okay. Ready?
Yes.
34.
374.
I have to now check.
Yeah. So as you do, it'd be good for you to have a calculator to check whether I've actually answered the question or just said a variety of three-digit numbers.
That is correct.
Another one, please.
Very nice. Really good. Okay, another one. 61.
671.
671. I should be able to do that one in my head properly, actually. 671, yeah, excellent stuff. So we've got 2. That's really nice.
Okay, so have you got any people on the chat? I'm not going to look at the chat. If you want to just pick some random numbers so they know that we're not colluding.
Yeah, we're not colluding. I will have a look at the chat. Just give me 1 second.
Sure.
It's buffering currently, which is never what you want to see. So just give me 1 second and I'll...
It's all right. You can think of another one if you want to keep the momentum going, keep me thinking.
Okay, so let's go for 87.
957.
957, what do we think? 87 multiplied by 11 is amazing. That is 957. Okay, I've got some coming in on the chat now.
Right, I'm not looking, so you tell me.
Okay, so let's go. Poppy says 79.
Okay, 869.
Is correct.
Okay, I'll do one more, then I'll show you how it's done.
One more, okay. Let's have Manta X with 42.
Oh, great. 462.
462 is correct. Amazing work.
Right.
Awesome. How is this done?
So as a maths teacher, obviously, I quite like to give a thing and then I want to explain how it's done because I like to explain things. It's my job. So let's say the first number you said to me was 34. Can you see my screen? Yep. And that's times 11. And all you have to do for this, I'm going to show you how it works and I'm going to explain why it works after. Okay. So 34 times 11. All you have to do when you're multiplying by 11 for two-digit numbers is you separate the two digits, 3, 4, and then the number in the middle of those two digits is the two digits added together. So it's 3 plus 4, which is 374. Okay.
Very nice.
So if you think of another number, it works the same way. So if someone said 42, okay, nice and easy. So we do 42 times 11. Okay, we just separate it. What would it be? 4 and 2, and in the middle 4 plus 2, which is 462. Okay, when does it get a little bit more complicated, do you think?
Is that a question for me? Yeah, I'm guessing there's no one else to answer, is there?
Sorry, on the chat. But so Zoe, if you think about when would it get a bit more complicated?
Well, I guess when the 2 that are being summed in the middle are going over 10. So
that's 10. The key thing. So if it's less than 10, it's very, very simple. If it's more than 10, it's not much more difficult, but a little as an extra step. So if we think a number to do 65.
So let's 65.
Oh, you pick one. Oh.
Okay, let's do 77.
77. Okay, so 77 times 11. We separate 7 and 7, and in the middle you're going to have 7 plus 7, which is 14. So 14. So we're going to carry the 1 from our 10, so that becomes 8, 4, 7. So if it goes over, just add on 1 to the first number.
Right. Okay.
It. And so if ever imagine you're going to a restaurant and there's 11 of you and there's a set menu and it's like £25, you can work out quite quickly without a calculator.
Helpful for a very specific occasion.
You're welcome. But also, but I'll show you why it works. So the algebra for it is actually really quite nice. So it's like a really cool thing to do. Even if you don't like fully get the algebra, that's a trick you can do, a mathematics trick you can just like take with you and wow some people. But let's imagine it's a 2-digit number and it could be any 2-digit number. So we'll call it A and B times 11. Yeah, so that's our 2-digit number A and B, because that could be any of our digits. And we'll do a little bit of long multiplication. Exciting. So AB times 11. Okay.
Yep.
So do 1 times B. 1 times A, AB, and then we're multiplying by the next number. I think have your placeholder because we're effectively multiplying by 10, not 1. So that's 10 times B, so that's B and then A. And so when we do our answer, we've got B, and then the middle number is A plus B, and then our number there is A. So that's kind of why it works. It's very simple maths, but it's also quite effective.
Really nice, and I'm convinced that it will always work now for any 2-digit. And which is, I guess, the power of algebra.
If someone asks you what's algebra used for, then just say the 11 times table trick. It's a good one.
Yeah, and there's like loads of different magic tricks which you can sort of prove that they can work for any numbers by using algebra and representing, thinking about place value in algebra and stuff. So that's really lovely. Have you tried this out on your students? Do
you know what? I haven't. Like, well, some of them might be watching, they might not be. So on my first day back after half term, I think all of my classes are in for a real treat when I do this.
Yeah, they will be. A treat, a Halloween treat, almost Halloween treat.
Yeah.
Yeah.
Also go on.
Sorry. No, Carol.
I was going to say, I've got, that was my trick, but you did actually sort of say to have a treat as well. I have actually got one prepared if you'd like it.
I would like to see your treats. Yes, go for it, please.
Okay, so I'm going to have to take my calculator ring off. It's a shame. So I've got to put on for this treat, because as a maths teacher, I know a lot of people actually have issues with times tables, like multiplication tables. And like, do you know which multiplication tables are like the hardest for people to like remember? What would your guess be? Being a previous teacher? Yeah.
I would say, I'm just thinking also about my own, maybe 6 and 8, something like that.
Yeah. So as in, I don't fully know, but I know that as a teacher, I've witnessed that a lot of kids are kind of really happy up until the 5 times table, and it just gets a little bit foggy after that. And so, and actually, if you know your 5 times table, you kind of know them, the 6, 7, 8, 9s up to 5, but it's that bit in between where it's 6 times 6, 6 times 7, 8 times 7, 8 times 8. A lot of people find that very difficult. But I've got a hand trick that can help you with those really difficult ones. So everyone watching, I'd like you to try the trick. You might see, I don't know if you've seen it before, but it's for the 6, the 7, the 8, and the 9 times table, and multiplying them together. So, Zoe, do with me. So at home, I'd like you to try this as well. Can you see my marigolds? I can. It took a while for me.
So you've got 6, 7, 8.
Yeah, and 9. So 6 is the thumbs. So 6 is your thumbs. 7 is your index fingers. 8 is your middle fingers. And 9 is your ring finger. Okay, so that's kind of how it works.
Perfect.
So how it works, and I'll give you an example. If we do 8 times 7, so your middle finger and your index finger, doesn't actually matter which order, because 8 times 7 and 7 times 8 It's the same. And how it works is you're going to count the numbers above the fingers that are above and including the bridge. So you've got 1, 2, 3, 4, 5, and they're your tens, which is 50. And then under the bridge, you multiply your digits. So 3 times 2, which is 6. So 7 times 8 is 56.
Oh, nice.
Okay. Do you want to try another one?
Yeah, let's do another one. Yeah.
Yeah. You pick.
Okay. So I'm going to do one that I think people might find hard. So let's do 8 multiplied by 6.
Cool. Right. So thumb, one of your thumbs, and then the middle finger, like so. So let me count how many numbers including your bridge. So 6 times 8. So you've got 1, 2, 3, 4, which is your 4 tens, and then you multiply the digits underneath. So 2 times 4, which is
8.
All together.
So at the bottom, sorry. So you got 4 at the top, and you've got. I got distracted because I turned my hands around and then it wouldn't work anymore. So you got 4 at the top, and then you got 6 at the bottom. Right. So 40.
Oh wait, no, it's 4 times 2. Oh.
What have I done wrong? So I think I've done this.
Right, start again. We'll do it together because long.
Yeah, I did it wrong, I think.
Right, so work with me. So 6 times 8, yeah?
Yeah.
So you've got your thumb, and then you've got your middle finger for your 8. So thumb is 6, 8 is your middle finger. Put them together, and then you count the digits above, including the bridge. So how many have you got?
I've got 4.
And then underneath, you're going to multiply them together. So you've got
multiply. Sorry, that's where I went wrong. Sorry, 40. You're saying that as well. It's just like my brain is fried after trying to memorize 40 coin flips. 4 times 2 is 8, so I'm happy that's 48.
That's 48.
Yeah.
Oh, and I should have actually said so that this works for your 6, 7, 8, and 9 multiplied together. So that's kind of quite a nice thing that, if you ever were asked that question, you could use your hands. You don't have to learn them all, you can just use your hands.
That's really nice. Are you gonna let the audience have a think about why this works at home, see if they can investigate that for themselves, or do you want to?
Yeah, I'm not going to explain why this works. This is me as a teacher saying this is your homework now. Go off and have a think why this might work, because it does. We've shown it that it does. And why does it work? Why doesn't it work when you get to the digit 10? What happens there? But I don't have the answer, so I'm actually quite interested to know what people kind of find out.
That's nice. I think that's my homework too. Thank you for teaching me that. I'll remember that. What I did was I turned my hand around that way and then it just went wrong. So don't do that.
You might want to invest in some marigolds that you take with you everywhere. It's a thing that you could do.
That would help me out. That's really lovely. Thank you for sharing those tricks, your trick and your treat. And I really like, especially the first trick, the way it's something that can help students and adults and everybody really, if they're doing multiplication. But you've also shown us why it works. So sort of, I don't know, I'm going to use some teaching words now. I feel like that's fluency and reasoning, or fluency and understanding, or something, all kind of meshing together, which is really nice. And so I think it's probably time to have a bit of a chat about stuff that you've been up to recently. Have you got any other projects coming up soon, or things you've been working on recently?
Well, so I regularly do stuff. I've got like a website, and I'm on Twitter and on Instagram as Do the Maths Thing, because I want everyone to do the maths thing. And recently you mentioned Maths Inspiration. I sort of did that earlier in the month, which kind of again was able to share. And I also did Maths Week Ireland, where I was able to share a variety of different things on multiplication tables, which is a real kind of interest of mine, because I think that we don't spend enough time playing with this topic, which we expect students to know. Like, kids are getting assessed on it at the age of like 6 or 7, and we're not really going into the patterns that are there, which are really beautiful and quite fun. So that's like one of the things that I'm kind of hoping to do sort of more work with. And obviously I'm a teacher, and back in the classroom with regards to kind of trying to get kids through exams this year that didn't happen last year, and working with teachers with maths hubs with a view to helping them think about effective ways for sort of teaching and collaborating together, but obviously now done virtually, which is kind of a new existence.
Yeah, I guess everybody is adapting very quickly to these new the new environment essentially. So I guess over the summer until the summer holidays, were you mostly teaching virtually? I realize some students were in schools. Were you doing a lot of virtual teaching?
Yeah, pretty much. I went in to teach the year 10s because I think they were brought back, and I was sort of teaching maths in the gym, which was interesting. Kind of social distance mathematics in the PE room. And then was doing like virtual lessons with sort of a variety of classes, which again is funny because it's not quite the same as having the interaction they're like an audience. I suppose you understand this as a maths communicator, but at the same time still quite rich, like it was really, it's I do think we're in a new kind of space now where technology is being kind of used, and I'm not going to stop that because it's kind of where we're at now, but there is a space for, I'm looking forward to more kind of like bigger like productions where you'd be able to sort of see everyone and be in like a theatre sort of doing performances and stuff.
Yeah, no, that would be exciting. I was going to ask you also about your kind of your own personal math story. I don't know if there's a defining moment in your life when you realised maths was for you, or if it was a sort of long, gradual sort of moving towards mathematics. What's your mathematics story?
Oh yeah, I suppose this is what I asked you on our podcast, wasn't it? So my story is not that interesting, to be fair, but like I always enjoyed maths at school. I didn't think I was great at it, but I enjoyed it. And then I did a degree in it, which was fine, but I found it challenging. And then I really, really, really loved, there was a unit called Maths Education. And it really fascinated me how people learn this subject. And then I sort of did teacher training. And with the teacher training, I kind of suddenly saw that a lot of people had really bad experiences with maths. I'm very negative towards it, and even before they began to do a question, they'd have given up, and it was a shock to me because I just hadn't really experienced that. And it also made me feel sad because, I sincerely believe that maths as a subject, if you find it challenging but you kind of get over the hurdle, you feel good. I think it's like a real, like, sounds really hippie, but I do think it's great well-being. Like if you are confident with it has a massive impact on your kind of well-being. You're like, there's actually correlations. Like, there's been loads of studies to say that there's a big correlation between people who have issues with numeracy and depression, or have really bad with regards to finances, and that's like people's lives. So I kind of got into teaching and wanted to sort of, I didn't realize it was an issue, and the more I taught, the more I was like, oh, it's really, we need to get more people engaged and like into maths. But I also know that's about how we present it. And that's why I like kind of doing like the whole playful thing. I think a lot of people who love maths, like that's brilliant. And I think it's great that there are shows for that and stuff. But I also feel there's like a real space for people who don't love it yet, but want to.
Yeah.
And also know that it's important. And it's stuff like, so the work I've been doing with multiplication tables has been really great because like everyone can access it. Do you know what I mean? It's kind of, it's the type of thing that like either some people like are good at the times tables and some people have always been quite bad at them. But as soon as you give them a way in to access it, they get kind of engaged. And that's like I said, the power. That's why I love teaching. So I'm hoping to do more stuff like that, where it's about kind of breaking down the walls of not elitism, but that thing, if you don't get it, you're out. I think I'm hoping that more people, I want to do more stuff which gets more people involved and engaged in maths, and like playing with it, like, learning that trick, understanding why it works, and then showing their friends and practicing it.
Yeah, that was. I wish I was in your class. Essentially, is going to my summary to what you've just said. I could. It sounds like the more you teach maths, the more you realize why you want to teach maths, and the more you enjoy maths. It's like a sort of like a symbiotic sort of cycle, isn't it? I remember when I started teaching, I started understanding more about maths, and because I'd never really thought about how do I understand this, and what are the kind of barriers to overcome. And when you start teaching other people, you realize how much you enjoy it yourself. So it's really nice to chat to a teacher again and pretend I'm in the classroom still.
Also, I have to say, like, events like this, it's really great to be involved in, and to sort of seeing the massive community of maths people. I mean, what's the collective term for mathematics people?
Mathematicians? I mean,
yes, pretty much. That's quite a lot. But like
maths communicators, I guess, people that are doing this sort of thing.
If there's a collective noun, anyone share.
Yeah.
But just the whole idea that we've got such a wealth of people who are up for sharing some really interesting and fun ways that, I think some people, if you were to say to them 24 hours of maths and magic, they'd be like, oh, that's awful. But it's kind of like the lineup is huge and it's also really exciting. So it's kind of, I think maths is in a really great place. And I think in some respects as well, like, the virtual element of it is great because it's getting to so many people in their houses, which is amazing, and it's for a great cause. So this is like great to be a part of this, really.
Thank you. That feels like a lovely point to end on. So you've just sold the whole show to me. So yeah, hopefully people can have been watching the last half an hour, Susan, and then they're now hooked on maths and they want to get a little bit more. Thank you very much, Susan. You've been awesome. I'm going to say goodbye to you now and hand over to my next guest in a minute. Thank you very much. See you, Susan.
Have a great 24 hours.
Yeah, we'll do.